Hello students, how are you? Hope you are all well and doing very fine in mathematics. In my previous classes, I have already taught you two chapters. The first one is a pair of linear equations in two variables, and the second chapter quadratic equations. We have already finished it. Now we are going to start a new chapter, that is arithmetic progression. This chapter is very easy and marks scoring. So here also you will get some word problems, but comparatively it is easy. Take my words, just little bit of thinking and meticulous doing, you can able to get full marks in this chapter. So with this, let us start. I am L. K. Naik. So I want to request you that if you have not subscribed my channel, please subscribe to motivate me. Let's start. Today it is our introduction class. After this introduction only we will go to the exercises, whatever is there. Now let us see some example. If I write 1, 2, 3, 4, ... Here what you see, this ... represents a series. It is continuing. 1, 2, 3, 4. This dot shows that the next one will be 5, 6, 7, 8, 9, 10. It will go on. Next, let me write it 2, 4, 6, 8, ... One more example. Say -6, -9, -12, -15, ... Suppose -10, -5, 0, 5, ... 0.1, 0.2, 0.3, 0.4. So you might be thinking what I am writing. Dear students, you see here in the first example 1, 2, 3, 4, there is a pattern. You see every number, each number whatever you see, it can be obtained by adding 1 to the previous number. 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4. Similarly 4 plus 1, 5, 6, 7, it will go on. In the next 2, 4, 6, 8. If you add 2 here, you will get 4. If you add 2 here, you will get 6. If you add 2 here, you will get 8. So this is again a pattern. In this, you see -6, -9. If you add -3 here, you will get -9. If you add -3 here, you will get -12. If you add -3 here, you will get -15. So similarly, it will be -18, -20. It will go like this. This is again a pattern. Here you see -10, -5, 0 and 5. -10, if you add a +5, you will get -5. +5, 0. +5, here you get 5. Again, it will be again 10, 15, 20, like this it will go on. Here, 0.1, 0.2, 0.3, 0.4. If you add 0.1, you will get 0.2. If you add 0.2 here, you will get 0.3. If you add 0.1 here, you will get 0.4. So, these things, what I have written here, these are the list of numbers. These are the list of numbers where each term we can obtain. Each and every term in this list can be obtained by adding a finite number to the preceding term. Suppose here 3, how we obtained? By adding 1 to the preceding term 2. Here, what is term 4? Now if you add 1 to the preceding term 3, you are getting 4. Similarly in all the cases, in this case if you add -3 to minus 9, then you will get minus 12. So each term we are getting by adding a fixed number to the preceding one. Isn't it? Here, what is the fixed number we are adding? We are adding here 1. 1 plus 1, 2 plus 1, 3, 3 plus 1, 4. What we are adding here? 2 plus 2, 4. We are adding it 2. We are adding 2 here. 2 plus 2, 4. 4 plus 2, 6. 6 plus 2, 8. Like this way it goes on. Now here, again, what we are adding? Minus 6, minus 3. We are adding here minus 3. Here what you are adding? Plus 5. Here what you are adding? 0.1. 0.1 plus 0.1, 0.2. 0.2 plus 0.1, 0.3. So what are these? These are the fixed numbers. These are called actually, these fixed numbers, what we add to a given number to get the succeeding one, this is called the common difference. Common difference. Common difference. And what is this one? This, in this series, one is called the first term. This is called the first term. First term of the series, or first term of this series of list of numbers. Similarly, in this, it is 2 is the first term, minus 6 is the first term, minus 10 is the first term, 0.1 is the first term. So dear students, so we have seen such type of patterns are actually called arithmetic progression. There are 3 types of progression: arithmetic progression, geometric progression, and the third one, harmonic progression. As far as geometric and harmonic progressions are concerned, these things you will study in higher classes, in class 11 and 12. In our syllabus, in class 10, you have only arithmetic progression. In arithmetic progression, what we do? There will be a series in which each number will be obtained by adding a fixed number to the preceding one. Each number, I will again repeat, each number in this list will be obtained by adding a fixed number to the preceding one. So this fixed number what we are adding to get the successive terms, isn't it? You are adding 3 to here, 3 to here, this 3, which is the called common difference. The fixed number or the finite number, you can say, the fixed or the number, you can say simply the number which we add to a term to get the next preceding number is called the common difference. And the very first number in the series is called the first term. It is understood from the name itself, first term. The term which is the first in the series. So I hope you have understood what is the first term and common difference, isn't it? So now again let us analyze. So in this series or in this list, 1 is the first term, 2 is the second term, 3 is the third term, 4 is the fourth term. In this similarly, minus 10 is the first term, second term, third term, fourth term, fifth term, sixth term, like this it goes on. So term you can understood. Each and every number in a series is called the term. So this is clear. Each and every number in a pattern. You see, each and every number in a pattern is called the term. 2 is a term, 3 is a term. Here in this AP, 6 is a term, minus 9 is called term. First term, the term which comes first in the series is called the first term. And the common difference is that number which we add to a given term to get the preceding term. You will get the definitions at the end of this class. So don't worry about the definitions, and also remember that nobody is going to ask, never ever, nobody is going to ask the definitions. Your concept should be clear. Common difference means it is a number. It is generally represented by difference, D, small d. Common difference, you see, common difference nothing but the number which is added to a term to get the succeeding term. The example of D can be 1, it can be -1, it can be 0, it can be also √3, it can be 2/3, it can be 0.25, like this. It can be any number, any real number. It may be plus, it may be minus, it may be fraction, it may be decimal, it may be irrational. D can be anything. So you have understood the common difference. Now, what is finite arithmetic progression? We'll come to the definition of arithmetic progression later. So I hope it is clear. Again, I will repeat. So in this case, this is called the first term, second term, third term, fourth term, like this it will go on. Now, what is a finite AP? Finite AP means what? Now, in this case, you see these three dots. These three dots signify that there is a never ending. It will go on. So, such type of, a finite AP means, how to write a finite AP? Suppose you write from 10 to, then you write 6, add 4, it is 10, add 4, it is 14, add 4, it is 18, add 4, it will be 22, add 4, it is 26. And suppose you want to end it here. Then this will be called a finite AP. A finite arithmetic progression means the number of terms is not infinite, it is fixed. It cannot go never ending. No, it is not a never ending story. But if I write, suppose if I want to write 1 to 100, 1, 2, 3, comma, 100. Now you see how to write this. You have to use comma, only 3 dots. This is the convention of writing. You should not put 2 dots, or you should not put 4 dots, or you should not forget to put the comma. So this you see, comma here, 3 dots, comma here, again 100. What is this? This is actually a finite AP. Finite AP. Here you should also add one thing called, I forgot, sorry, last term. Last term. There is also a term. As it is a first term, that is a last term. So in case of finite AP, you will get a last term. In this finite AP, 26 is the last term, 2 is the first term. In this AP, 1 is the first term, 100 is the last term. But in the case of infinite AP, there is nothing called a last term. In an infinite AP, because here the number of terms are not fixed, it is never ending. It is never ending. So here there is nothing called a last term. So in case of an infinite AP, there is no such thing called last term. Yes, but first term is there. Whether irrespective of AP, whether finite or infinite, you will have the first term and the common difference. The thing in these two difference is that in case of infinite AP, there will be nothing called last term. But the same you will get in the finite AP. I hope I have made my point clear. So in case of finite AP, the number of terms in the given AP will be fixed. It may be 1000, 10,000, 20,000, it may be 2, 3, 4, but it is fixed. You can say how many number of terms are there. You can say that number of terms in a finite AP is fixed. But in the case of infinite AP, the terms are not fixed. As you know, if there is no end to a natural number. What are natural numbers? It starts from 1 and ends at infinity. Isn't it? So like that way, there is no end to it. Similarly, infinite AP, there is no end to the terms. So the number of terms in infinite AP are not fixed. But whereas in the case of finite AP, the number of terms are fixed. So you will get a last term. But in infinite AP, you will never get a last term. So I hope this has been clear. Now let us see about the general form of an AP. This is the things, it is for introduction to make you understand how to write the general form of an AP. Now, the first term, there are two, bear in mind, there are two important things. There are two important things to write an AP. There are two important things to write an AP. Maybe it finite or it may be infinite. It doesn't matter. But you need two things. One is the first term. First term. And the another one you need is common difference. If you know these two things, you can write the AP. First term is represented by A and the common difference is represented by D. The first term is represented by A and the common difference is represented by D. So, general form. How to write the general form of an AP? Now, first term will be A. Now, what will be the second term? I told you to get the second term, you have to add the common difference. You have to add the common difference. Suppose if I write 4, suppose I write 6. The first term is 6 and the common difference, suppose the first term is 6. And the common, I will write it somewhat here. Suppose the first term A is equal to 6 and the common difference D is equal to suppose 4. Then what will be the AP? First term is 6, common difference is 4, so you have to add 4, it will be 10. Add 4, it will be 14. Add 4, it will be 18. Like this way, successfully you are adding D. Means with this first term you are adding D and you are getting the second term. With the second term you are adding D, means 4, and you are getting the third term. Like this way you are proceeding to get the AP. So if suppose A is equal to minus 10 and D is equal to plus 2, how will you write? A is minus 10 and you add 2, it will be minus 8. You add 2, minus 6. You add 2, minus 4, and so on. And so on. So how you are getting this successive terms? To the first, this is the first term, you add plus 2, you are getting second term. You add D here, you get the third term. You add D here, you are getting the fourth term, like this way. So in general, what we can write? We can write A. Now you add to a D, you add A plus D. Now again, with this second term, you have to add D. To every term you add D, common difference. So it will be A plus 2D. Isn't it? You got the third term. Now again in this case you have to add D. So you will get what? A plus 3D. Okay. So like this way it will go on. About this we will study in details in the next class. So this is the general form of an AD. AP, arithmetic progression. This is A plus D, A plus 2D, A plus 3D, A plus 4D, A plus 5D, like this it will go on. Like this it will go on. This is the first term. First term, and D is the common difference. So this is the general form of an AP, arithmetic progression. So this also finish. Last time I have already told you. Now definition of an AP. It is very easy to define. So let us have an example. Suppose you are having 5. You are adding 10, you are getting 15. You are adding 10, you are getting 25. If you are adding 10, you are getting 10. It is 35. So like this way it is going on. 5 plus 10 plus 10 plus 10. So what is definition of P? Definition of P means it is a list of numbers, or you can say a series of numbers. Okay. An AP means an arithmetic progression is nothing but a series of numbers in which each and every term is obtained by adding a fixed number to the preceding one. Clear, students? I will again repeat. You see, One thing I will again and again tell you, nobody is going to ask the definitions. In mathematics, it is generally never asked. I have never experienced, I have never witnessed in my life that somebody in any paper is asked what is AP. Because mathematics is not meant for this. You have to solve questions, but if you know the definitions, you will build up your confidence. Yes, you know something. So that is the usefulness, the utility of getting the or knowing exactly what the definitions are. So what is an AP? AP is what? A series of numbers or a list of numbers where each and every term is obtained by adding a fixed number to the preceding one. Preceding one is the earlier one. So this is what called an AP. The definitions is already given in the book. So dear students, let us now summarize. So you have understood. So if I write, suppose for example, 6 suppose for example I write 6 then minus 3. If you add, it will be 6 minus 3, it will be 3. Minus 3, it will be 0. Minus 3, it will be minus 3. It will be minus 6 and so on. Now here I will summarize. Each and every things are called, each and every numbers here is called the term. Each and every number here 6, 3, 0, minus are called term. This is a term. First term, 6 is the first term. Common difference. How to get the common difference? You write any number here. You take any number. Suppose you want to take 0. You take 0 and subtract it minus the preceding one 3. It is equal to minus 3. You take this one. Suppose if you want to take minus 6. Minus 6 minus of this is minus 3. So it will be minus 6 plus 3. It will be minus 3. You see. So this is called the common difference. The fixed number which we add to each number to get the succeeding one. Or you can say each term is obtained by adding a fixed number to the preceding number. Okay, so that fixed number is called the common difference. Finite AP, when the number of terms are fixed in a given AP, that is called a finite AP. Example, suppose if I write minus 50, minus 40, minus 30, minus 20, minus 10, 0, 10, 20, stop. Now here, okay, this is a finite AP because here the number of terms are fixed. How many number terms are there? 1, 2, 3, 4, 5, 6, 7, 8. So this in this AP, the number of terms are finite and that is equal to 8. Where minus 50 is the first term and what is the common difference? Common difference will be minus 40 minus of minus 50. This minus this. Or this minus this, this minus this. So it will be equal to minus 40 plus 50, that is equal to 10. So here the common difference is 10. In case of finite AP, you will get the last term. Here the last term is 20. First term is minus 50. Number of terms 8. Okay. But in this case, there is nothing called last term because it is an infinite AP. And the general form of AP, I told you, general form of AP is written as A plus D, A plus 2D, A plus 3D, comma, dot, dot, dot. First term, second term, third term, fourth term like this. Now, definition of AP. Definition of AP means what? It is a list of, an arithmetic progression is nothing but a list of numbers where each and every term is obtained by adding a fixed number to the preceding term, except the first one, because we don't add, except the first one, we don't, this is nothing we add here. There is no preceding term for the first term. Clear, students? So how to know whether a given series is in AP or not, isn't it? If you know A, then you can find, if you know A and D, you have to know two things, A and D, to frame one, to write the AP, isn't it? But if a series of numbers is given to you, or a list of numbers is given to you, suppose a series given to you like this, suppose 5, 4, 0, -4, -2, ... Now you want to know whether it is in AP or not. So what to check? It's very simple. You do 4 minus 5. It is giving you what? -1. Then you do 0 minus 4. What it is giving? -4. No, it is not an AP. Simple. It is not an AP. Clear? Because the common difference is not going to change. Mind that the common difference is not going to change in a given AP. If the AP is given, then it's a first term and the common difference will be fixed. If the common difference changes, then no. Then the difference will never be called common. The name itself, the differences should be common. The difference between this number should be common. I mean, same. But it is not same here. So therefore, this is not an AP. Dear students, so this is all for today. This was just a bit of introduction only. In the next class, we will do the nth term of an AP and how to find the sum of the terms of an AP. After that, we will do exercises. Clear, students? So I will see you in the next class. Thank you. Enjoy life and enjoy maths.